Okay, year 13. So in our last lesson, I started very quickly going through section 11.10, which was solving differential equations. We did the first example and we ran through the concept, but I don't think we did the second example. So I'm going to do that today just to help you out with having a go at the questions. And then Monday's lesson, I will do the next section. So when we looked at solving differential equations, it was if we have a differential equation that is a function of x, which you are used to, but also involving some function of y. So we're used to functions where it's, say, dy by dx equals 3x squared. If dy by dx is 3x squared, we can easily just integrate that. We would get 3x cubed over 3, so it's just x cubed. We can't just do that, however, if there is a function of y involved. If we turn this into 3x squared y, we can't integrate that using the same method. We would need to separate the variables so that they are on the correct side to be integrated with respect to the variable that they are in. So I'm going to get rid of this one. Not a fraction, but we split it as a fraction. So I'm going to multiply by dx. And then I want to get everything with x on one side, which I have, and I want to get everything with y on one side. So I'm going to divide by g of y. So this is what I'd end up with, and this is what I would then integrate. The first example, which we've already gone through in lesson, is finding a general solution. So that means that you're going to end up with a constant term because we haven't got a point to plug in of this equation. So what we want to do is we want to get all of the y's on one side along with dy and all of the x's on the other side along with dx. So I need to take the 1 plus x squared over to this side. So I'll have dy by dx equals x tan y over 1 plus x squared. I'm going to multiply through by dx. So that I've got that. And then I'm going to divide by tan y. So 1 over tan y dy equals x over 1 plus x squared dx. And I'm going to integrate both sides of that. Turn this 1 over tan y into cot y, so that we end up with integral of cot y dy equals integral of x over 1 plus x squared dx. And then we can just integrate that. So integral of cot y, that is log of sine y. Use reverse chain rule to get there. And then because this is a multiple of the derivative of the denominator, so again it's going to be a logarithm. It's going to be log of 1 plus x squared. If I differentiated this, I would get 1 over 1 plus x squared because of the logarithm. And then I'd have to differentiate this, which would give me 2x on the top, but we've only got x, so it must be a half, and then plus some constant. If this was a log of some sort, we'd be able to combine them using the log laws. It's a constant, which means we can call it log of some other constant. So this is still just a constant. Log of a constant will just give me another constant. So I've relabeled c to be log k. It doesn't really change anything except I can now combine it with this. So I've got log of sine y equals, I'm going to do log, firstly, of this 1 plus x squared to the half, using the fact that this multiplier here can be brought up as a power. And then, if I'm adding two logs, I can multiply what I'm taking logs of. So it's going to be k times 1 plus x squared to the half. Because it's logs on both sides, I can just ignore the logs and say that means sine y equals k root 1 plus x squared. And that is the solution.